We're going to study predicting products doing this reaction, ozonolysis. This reaction, when we use this reagent, what we're going to be doing is cleaving, breaking a double bond, and inserting oxygens, one on each side of the double bond. So here's what you do to predict products. You're going to do this. You're going to break that. And then we're going to insert an oxygen on each side. But notice this is a symmetrical alkene. So when you insert that oxygen to this side, you're going to form this ketone. But at the other side is identical. So you are forming two moles of the same. So let's do the molecule below. So in the molecule below, again, we're going to be breaking that double bond. And you will be inserting an oxygen on that end, on one end. So let's do that. This. And you have here one carbon. So you're making another product, which is formaldehyde. So that carbon with two H's. So you have here two different products because this alkene was not symmetrical. So again, that's only one carbon that makes these formaldehyde, and in the other end, you insert an oxygen. And now let's do one more. And here you have a cyclohexene, one methyl cyclohexene. You can break in that there. You're going to insert an oxygen on each side. First, to make it easier, we're going to just draw it the way it is. And then we're going to say unfold it. So notice, since I have an H, this is an aldehyde. Because here I had a metal, now this end is a ketone. And we have total, let's count carbons. In the cycle, you had 6 and 1 extra over there. So this side, this is that end. And then you're going to count 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, and 6, and you're going to insert an oxygen. So that is the product for the other end. So again, what you do is simply insert an oxygen on each end. So that end here is a ketone, that side, and the other end is an aldehyde. Okay? So do I see that? I don't think it is. I hope it can be seen. So in this end, we have that aldehyde. Okay. And so let's do that one, which is harder, right? So it has two double bonds. One is a exocyclic here, and the other is endocyclic. So we're going to be doing the same. Now we have more products. Notice here, because it was symmetrical, I had only one product, but it's 2 moles. Here you have 2 different products, the ketone here and formaldehyde. Here, because the double bond is part of a cyclic structure, you have only one product. But on that end, it was a ketone, the other end was an aldehyde, since we didn't have a substituent on the side of on the double bond. Okay, but now here, let's see how many products can we form. When we break that, we're going to form formaldehyde for that side. And here you're going to add an O, but you're also going to break that. So let's do the structure and then say we unfold it. So we're going to form first formaldehyde, which is the one there. Then we're going to be breaking all of the other bonds. See, this is that. And here you will have double bond O, that's that. And here I have, I'm going to detach it a little bit. That's that end. So because we didn't have a substituent here or here, these 2 ends are aldehyde. All we need to do now is kind of unfold it this side. So what I did it first that way so that you see that you simply break the double bond and you insert the oxygens. So now I'm going to unfold that. And remember that that's one product, but you had also formaldehyde. And when the double bond was part of a cyclic structure like this one, you're forming one product. Okay, so let's zero on this one. So I'm going to start. That was the easier part. That was aldehyde. Let me get another one. Let's see if this has more ink. Okay, so and on the other end, I have one bond and another bond. And now I'm not simply going to put it going down, right? 1, 2, and 3. 1, 2, and 3. Several ways of drawing, but now it doesn't look like that crowded, right? So the only thing you do is then ozonolysis will cleave, will break double bonds, and you will insert oxygens on each side. All right? So we will do more problems on alkene. This reaction is then ozonolysis. If you have a symmetrical alkene, you will have one product, like the first example that we did. Also, when we are part of an alkene. Another type of problems that you may have is given the products, predict what is the reagent. So going backwards, so say that we don't know that, but we do know the fragments after ozonolysis was done. Say that I have that one fragment in the problem says, for example, you obtain acetone and formaldehyde, and you didn't have the structure. So you draw the structure first. So acetone, formaldehyde. To see what was here, all we need to do is connect here and remove the oxygens. So next step will be connecting these two and removing the oxygen. So the structure of the initial compound is going to be that. So you can always check your work because you can do that ozonolysis. So ozone into DMS. And so that will cleave and form those two fragments.